My name is Mårten Ericson from Ericsson Research. I'm the work package lead of the work package 3 60 architecture design. So I will talk about the enablers there. We have defined the word enablers, which is some sort of area where we collect information, collect studies, and where we drive this. These are the enablers that we want to have on the 60 architecture. It will be a structure around the enablers very closely because I only have 15 minutes. Anyway, let's start a little bit about the overview of this work package start off. We have one task that are working on the data-driven architecture, as we call it, several enablers there. We have another task doing more traditional architecture design overall, the core network functions, the interfaces, and things like that. In that, we also have another task that doing similar things, but on the cloud and trying to develop the cloud to be 60 telco performance. And then we have what the task called new access and flexible topologies, working with more traditional resource management topics. And finally, we have a task working with the new services that we think that will be important to 60 with this, for example, sensing and compute device offloading there. So, but I will go through the enablers one by one, and there are quite many of them, but I will be quite brief. I hope you anyway can get a feeling what we are doing and what the enablers are. So we start off with the data-driven architecture. The end goal here is then, of course, the AI as a service. And we need several enablers for managing this, but the AI as a service is that to use the AI in network and also expose it to end users. So it's both. And this enabler, of course, need all other enablers here. So starting off with the ML operations. And this enabler, we are working here to enable ML or AI operations everywhere in the UI, in the RAN, in the core. And for that, we need some sort of management and how to deal with these models, how they can be run in the system. And also including security, of course, here, and privacy. But we also need data for that. The ML algorithms need the data, so that's the same thing here. How should we collect the data? How should we pre-process it? And how do you deliver the data to these different ML algorithms or processes? And then, of course, there is this, do we need any new protocols for this? Do we need any new APIs? We probably need some APIs to expose this also. What functions are necessary? That's architecture means here. So we have a scheme overview service. I will not go into detail here, but this is a little bit what we're working in this area about the different functions needed to run the AI model, repository monitoring and training and things like that you can see here. And this should also work in different cloud environments, so they should cooperate with each other. So it's also something we have to have it cloud native, of course. Going then to the network modernization task, here we have 3 different enablers. So the first is network modernization, and here we work with trying to investigate the optimal network function size, how granular it is. And we are dealing here with this, that is trying to be, we call it separation of concerns. Maybe heard about that, to avoid do a lot of signaling. And so if we try, the functions should be as separated as possible or closely coupled, we can avoid signaling, we can avoid interactions between different functions as much as possible, maybe improve the performance in the network. So that's what we're doing here, and that will impact a lot of different in the architecture, of course, and the procedure could potentially do that. And then we have the end-to-end design. It's also very related to these network functions, of course, they are very closely related. But here we do it to end system and more looking at the dynamic way also, how it should work. The modules should be moved around in the system, in the cloud or extreme edge, as we call it, or different parts of the network. And it's also more maybe looking at the interfaces necessary for that. Finally, we have the network migration. You can see this is the figure then for the cloud network. But anyway, go to the network migration is then to look at how should we migrate from 5G to 6G. And this will all, of course, limit what we can do here, or limit that it will. The migration is important to have a look at that, because it will in some way decide what can we do with the 6G architecture and modules and interfaces like that. This is one proposal we have about the migration, that the core network should be evolution from the 5G core network, and we add new network functions, 6G network functions to that. There will be a new RAT, and possibly we can go for lower layer split or not though. So that's about to. This is just ideas we have. We're investigating this. Another thing we investigate is this spectrum sharing between the different RATs. This is multi-RAT spectrum sharing, instead of using the rather complex dual connectivity between these different RATs. We think that spectrum sharing can be a more efficient way to handle the migration with 5G 6G. New access and flexible topologies, 3 different enablers here. The first is network and networks. It looks like this. And here we try to take the full picture of all different types of connections. We have the satellites on top here. We have drones. We also have what we call sub-networks, which includes maybe the multi-hop, or what we also call it. Yeah, this is some sort of management node taking care of different responsibilities in the sub-networks. This is then to improve the coverage and the performance. The user should not really know that they're using different sub-networks. And the multi-connectivity is a similar thing. I don't show a figure here, but it's also more than looking at the reliability issue of the network and network. So checking, is it then possible to have one more extra connection? Is it necessary? How do you aggregate between different radio access technologies? We have Wi-Fi included there also. And one of the issues we're looking into is maybe to have dual connectivity between the terrestrial network and the satellite networks. And everything about this is to increase the reliability, the robustness here, where the networks is more increase the coverage and the performance perhaps. So they go a little bit hand in hand. Another enabler here is the context awareness management, and that's a transport network. So to enable all these different networks and multi-connectivity with the transport network, we think also need to be evolved. The context awareness here is that the transport network need to know, we need to be aware what type of services it's transporting, and then behave a little bit accordingly, or different prioritization, things like that. So that's the idea here. Network beyond communications is, as I said, the different new services. The first enabler is called exposure and data management, and that's a little bit similar to what we had the data ops in the AI part there. But here it's about the data management from sensing or compute. How do you handle this data? How do you expose the data from these services to the end users, and also in network also? And that might require new protocols and interfaces. And then we have the protocols and signals for sensing, JCAS, and compute in itself. Here we may be more the protocols between the core network, RAT, and the UE in a total. We don't do any layer ones, no signal processing sensing here. That's another work package. We try to see a little bit more about the architecture here, of course. So this is that discover, compute, nodes, neuron interfaces for sensing and so forth. Then we had another more application-driven enabler, looking at what application is needed for digital twinning, or for example, or just using JCAS. So these studies are more investigating the need for different applications, but they are quite closely related to the first 2 enablers here also. This is the offloading example. This is a picture of the sensing also. Then last but not least, we have the virtualization and cloud transformation. Here I only show 2 different enablers here. This is the longest name of enabler, but it's about then how to orchestrate the different computing continuum resources. I'll show you a figure of this. We assume that we have different type of what you call layer of cloud compute here. So one is the extreme edge, and then we have edge and cloud resources in general. So extreme edge is then down to the devices, basically. And the idea is to investigate how these different resources can be optimized or how they work together, because it's not obvious that these can work together, how different are these different clouds with a different compute continuum. So that's the management part. The idea here also in this task is to set the requirements for the cloud so it can be transformed to have the 60 architecture. So it's closely related to the task we had previously about the modernization also, which also they are a little bit related here. So it's not only to drive the management, it's to drive the cloud, to handle the architecture, to drive the cloud transformation. The first one was then to handle the manage between these different 3-layer or compute continuum. Now, if you have different multi-domain clouds here, so a little bit similar but completely different solutions here. So what happens if operators have different clouds? How can they work together? How can operators that maybe have different platforms also? How should you combine this platform? So that's a multi-cloud federation, a multi-cloud here. So how do you handle the different resources in these in a unified way? And then we try to see the different requirements on the cloud, what is necessary to handle this. I will stop here. I think I'm a little bit ahead of time, but maybe it's good.
Thank you, Mårten. Maybe we have time to have a quick answer to a question that is related to migration from 4G to 5G, as there was multiple options. And the question is, in case there is area without a 5G network, is a standalone the only option, or there are alternative strategy for deploying a 6G alongside a legacy network?
I think what we are saying right now, that we don't want any non-standalone option for 6G. That's one of the lessons learned there by 5G, that this non-standalone option in 5G, but using 4G as a core network, that slow down the process of 5G, slow down the process of deploying new services and so forth. And yeah, it's also a big step to going from a new core network to an old core to a new core network. So that's why you want this evolution instead, a little bit smoother upgrading to 6G and using spectrum sharing between the rats. So I think that's, I don't know, I hope I answered that. Maybe you would like to say something also, Sylvain.
No, I just want to indicate that the question was rather focusing on case where area without 5G network. So how to handle that, but maybe you can answer in the chat.
Yeah, I can answer in the chat also. Yeah,
and then, because just to respect this tight agenda, maybe we will move to the next presentation. So thank you again, Mårten.